few months ago, I found and reported this local file inclusion vulnerability in a plugin called ImpressCMS, which is a part of ImpressCMS. Now, a word about ImpressCMS is that it's a content management system, kind of a WordPress, but much smaller. ImpressCMS is an open source project that gives users to create websites without coding at all. Now, in NVD, I got the score of 6.9 on the CVSS version 4, which is a bit underrated in my opinion, and here I'll explain why. But first, let's talk a bit about local file inclusion, or LFI. Let's jump to our Kali machine. I created this LFI demonstration for this video, and I'll put a link in the description to the Github repo for anyone who wants to use this lab to have some experience with LFI. And before the demo itself, I want you to see the vulnerable code in order to understand file inclusion vulnerabilities behind the scenes. So PHP has some functions that we can use for loading other files locally. We can use that to load images or other pages of the website. A common example is inclusion for loading pages in different languages, for example, English or German with the English.php or the e.php that we can load to have our website in multi-languages. Now, the thing is that the user input is unsanitized sometimes, and the attacker can load arbitrary files from the server. For example, let's try to read etc passwd. If we go to, for example, this path here, and voila, as expected. Now, the functions in PHP that actually cause this vulnerability is, of course, include, as we have here, but we also have other functions. We have include once, we have require, and require once. These functions actually do the inclusion itself. Now, another risk is that file inclusion may also be used to run code on the server. It happens because these functions here, they not only read file content. If the target file is PHP, for example, these functions also will render the file, causing the PHP code to be executed on the server, which actually leads to remote code execution. And now let's jump back to the browser to demonstrate LFI in action. We already loaded etc passwd, and of course that we can load any other file on the system if the web server has read permissions to that file. So let's also load etc host, and of course that we can read that as well. Now, let's say, for example, that we also want to read PHP code of this website if we want to leak code secrets or find any other code vulnerabilities. If we simply try to load a PHP file, it's just being rendered on the browser, but the code itself is still not exposed. For example, we have here upload.php. If here we will tell it to load upload.php, nothing really happens. Also, home.php, it's just loading the page itself here. Nothing really being exposed to us. In this case, we can use PHP wrappers, which is a cool PHP concept, and wrappers actually give us the ability to access different resources by using other stream protocols. In this case, we want to access PHP file, but we want it to be converted into base64, so it won't be rendered. So PHP LFI wrappers base64. and it takes a minute. Okay. So let's take this one for example, and also this one. And here you can see different protocols for PHP wrappers that you can also load. So files is pretty straightforward like we talked earlier, but you have also FTP, data, and here in data you can also include the base64 thing that we talked earlier. And in this example you can see the exact payload that it uses, pretty much also identical thing like we have, just instead of view we have page, and the PHP filter read convert to base64 encode resource, and it just goes to the PHP file itself. And in this example you can see it being loaded as base64 instead of being just rendered. But let's move on towards the juicy stuff, which is of course RCE. There is a thing called log poisoning, which is simply a way that attackers manipulate different logs on the target server in order to exploit them for RCE. Like we mentioned earlier in this video, the PHP inclusion functions also execute PHP code if it exists inside the file being included. So let's go back to the browser. And if we have permissions to read logs, we also may be able to manipulate them, and all we need is just to add some PHP lines in order to execute them. So the classic example is usually with Apache server log file, and in this case it's on var log Apache 2 and access log. And yeah, so let's read it first to see if we have the permissions, of course, but also how the log file is looking. Now, as you can see, we have here the user agent, which is also something that we can manipulate if we will take it with burp. So let's go here. And let's just say that we want this one to the repeater. We don't really need that right now. And all we want to check is if we can manipulate the user agent. So for example, let's just say exploit and send. Now let's try this again. And here we go. We have this loaded into the log, which means that we can also put here some PHP code. So let's just try, for example, PHP, a simple system command. Let's just say ID, and let's try to send it. Let's load it again, and here we go. So this is a classic example of log poisoning, and of course that you can put here any other payload. Let's go to revshells.com. And actually you can even get a reverse shell or just put any other web shell that you want. So we want to Linux, and we probably have some PHP options here. yeah. So here are different options that we can use with different PHP functions. This is a classic web shell. And let's just take the shortest one. It's a request CMD. But actually we can do something much more simpler. Let's just say PHP system, and let's say get request of CMD and finish it here. We will send it. Everything looks good. Proxy. Let's take it to the repeater. And here we first want to read that. So far so good. And now let's just add our CMD to ls. And there we go. We can see here the files that we have in the current directory of the PHP file that is being our web shell. So the thing is also relevant not only for the access log, but to every log on the file system that we have read permissions. So if we want to, for example, poison the access log, the auth log, we can use SSH, and instead of the username, we just put our malicious payload and go to the server that we want. Also, it works on FTP and any log on the file system that you can just read from the user of the Apache or Nginx server. Another way to achieve RCE with LFI is actually by file upload functionalities. Because if your target website has a file upload feature, and even if it's not vulnerable to file upload issues, like if you really only can upload PNG, JPG, or JPEG, for example, let's take this, please subscribe, upload. It is uploaded. Let's just check it on here under uploads. Please subscribe. It was a thing JPEG. And here we go. It was uploaded successfully. Now, the thing is that if you remember, I mentioned before that it just has to include some PHP code in order to be executed. It doesn't care. The PHP doesn't care if it's a PHP file or not. So in this case, let's move to this directory and go to downloads. We have this, please subscribe, and we can use exif tool to see that this file is currently a clean file, but we are going to add a little trick here. So let's add this comment, and of course just a simple PHP payload with, let's do the classic ID, and it should be fine. And yes, this PHP code was added as a comment in the metadata of this file here. So in a comment. So now let's just try to upload it again. And let's go back to the inclusion point, and it was under I just say under var www HTML upload, and it was please subscribe dot JPEG. Let's try to load it. And yeah, here's our code being executed on the target website. So it's just another very simple trick to get RCE with this LFI vulnerability. And like I said before, I think that giving this vulnerability 6.9 is a bit underrated. And let's jump back to the GitHub repository that I was reported to. And here, let's go to the repo itself. And let's go to the file that was vulnerable. And let's go to the history and view the code, the original code. And this is the code. So yes, it has the PHP extension at the end. So theoretically, we can't load any file that we want on the system, but only PHP files, which is still very dangerous, by the way. But take a look at this. This code is 13 years old, which means that also the vulnerability is 13 years old. And if you are familiar with PHP, so you probably know that 13 years ago, on 2012, we had a different version of PHP that had a special thing that we could exploit. So PHP version on 2012. And it was 5.4.10. Now, the thing is that PHP version nullbyte was available until this. It was fixed on 5.3.4, which is very close to the 5.4.10 that we saw earlier. So it means that if you go back to here, so this code was installed at the time on very legacy systems. That means that if we would do something like nullbyte, which looks like this, for example, we could bypass this .php extension and actually grab any file on the system that we want. So we could do again the log poisoning, we could read file uploads that we also poisoned, and we could read also different files that are informational and not only RCE. So this is why I believe that giving this local file inclusion vulnerability 6.9 in the CVSS is pretty underrated, because it's so old that it will be a match for RCE on different versions in the wild. Hope you know LFI better now, and feel free to download the demonstration from the link in the description to do some hands-on exploitation in your home lab. If you have any question about this topic, just drop a comment and I'll do my best to answer it. See you next time.